So welcome to the presentation of the decade. 2% milk versus whole milk. A decade-old dilemma by Josh, Jonah, Jeff, and Jane. Topic/investigation. So we all know that we live in a world with immense flavor and um just a lot of people have been the taste buds are very stimulated now more than ever. And we knew this, our group knew this, and we decided to put these taste buds to the test. We think that humanity has developed their taste buds so well that they could distinguish between anything. So, based on this prior knowledge, we predicted that 70% of Evanston Township high school students and staff could correctly distinguish between whole milk and 2% in a blind taste test. So, our experiment went like this. So first of all, we used a convenient sample to get our subjects. They walked in on a given Friday to a presentation room, so they had no prior knowledge of experimental actions or anything like that. So our factors were the type of milk, and our levels obviously were whole and 2%. And then we used the comparison method. So each participant was first given an initial cup for comparison. They were told which cup of milk they were given. This is either 2% or whole. After this, we gave them 3 additional cups of milk in a randomized order that neither the experimenter nor the tester knew. This made it double blind. We had a total of 30 different combinations, so for randomization, so it wasn't just like they were all whole, they were all 2%. There was 30 different combinations to spread out any variabilities. For the random assignment, we did simply just put 30 same size index cards and wrote the treatment numbers, and then when a subject entered, we had them pick a number out of the hat, and we gave them that treatment. At the end of the experiment, the subjects were marked as success or failure. Success meant that they identified all 3 cups, and failure means that they at least got one wrong. This is so we could eliminate the possibility that chance really played into the role of them guessing it right. Because were to get it, if they were to get success by chance, it would be a 1/8 possibility that they receive success by guessing, which is fairly low. It could be better, but fairly low. So most of our successes were probably successes based on taste testing, based on actually knowing the difference. After we did this, we got our results, and only 6 received successes out of the 30 participants. It's a nice picture here. Lessons learned from our experiment design. So the design experiment seemed to have affected a couple of the responses of the subjects. Participants that received whole milk as a comparison cup guessed the next one they tried was whole milk 63% of the time. Very surprising fact based on, I don't know, just a very surprising fact. Participant that received 2% milk guessed the next cup they tried was 2% 64% of the time. So they really liked just a surprising result. In order to improve the experience, we could have had the subjects rinse their mouths, and also we'll talk about this later, but maybe block the experiment based on gender or another factor that might play into confounding our results. We didn't really find any factors this time, but we could have done that, or could do that in the future. Simulation design and results. So after doing the experiment, we need to simulate our study with our assumption of 70%. This man also made us do it. To simulate the experiment, we used the simulation machine that you provided for us on the website with our assumption of 70% of participants would have gotten it correct. So in our simulation, our experimental value of 6 out of the 30 correct came up 0 out of the 200 trials that we ran. So the simulation was, we used a binomial simulation based on our 70% and 30 trials, and then we ran, and we saw how many successes we had out of the 30, and then we ran that 200 times. So then we made a graph out of how many based on the number of successes out of 30 for the 200 trials, and our experimental value of 6 successes out of 30 came up none of the times, and nothing even close. Even the closest one that came up was 11. We didn't attach the graph because we had some technology issues, but the closest proportion at the time was 11. 11 out of 30 came up once. So it's a very low number, 6 out of 30 from our simulation. So combining the pieces. Now we come up to the neat part. Was our prediction of 70% correct? Mr. Freeland thinks so. To assess this, we use the results from the experiment simulation and a theoretical probability. So, as we all know, the results are 6 out of 30. 6 out of 30 guessed it correctly from our experiment. To compare these to theoretical results, we're going to create a binomial variable. And this is going to be the number of people out of 30 who are success. And it's going to be distributed as n equals 30 and the p equals 0.7. So we're going to look for the probability that x is less than or equal to 6 if the probability is 70, is actually 70. So that is our claim, and we're going to test what the probability is based on our claim. So we could use a theoretical probability and plug that into our normal CDF and test whether or no, PDF, sorry, or CDF, sorry, I mean binomial CDF, and test whether the claim based our result, how many times our results or less than that come up based on the 70% claim. We did that, and the amount of times that should come up is almost negligible. 2.19 times 10 to the 8th, so basically 0. Furthermore, using the binomial model, we were able to determine the range of plausible experimental results based on less than 5% rule. So less than 5% rule means that it is the threshold, you can call it, of our of whether it's too high or too low of an experiment result. And so if the probability of that or a number or greater or a number or less, depending on both ends of the spectrum, is less than 5%, and the first number less than 5%, that means that is too far, too low, either too low or too high for us to assume that those values above that or below that will be viable for this model. So it's a little confusing, but based on this, and we were able to determine this from just honestly just guessing and they were just estimating and then calculating whether it was less than 5% based on our binomial PDFs or CDFs. We were able to determine that the plausible range was between 16 and 26 correct. And since our experimental results were 6 correct, we were very off. Yeah. Toledo. So, from the previous results, you could see that our claim of 70% does not really seem remotely possible at all. We only obtained 6 successes out of 30, so this is very far away from the plausible range of successes within with using the less than 5% method, and the theoretical computed probability based on that 70 was basically close to 0. So we were very off on our claim. I'm probably going to make it lower to much lower, maybe 50%. I'm just guessing right now, but um, our claim of 70% of people that could tell the difference was very off. But it's okay. There's not a whole lot really to be done in the future for this. The qualitative observations that we made were only about gender, and we randomly it was pretty random, 16 males, and we got about half and half, 16 males, 16 females. I don't really think that confounded the results that much, but or affected them, but maybe in the future, as I said before, also blocking by certain attributes. So either regular milk drinkers or people of a certain age, as I know people usually a lot younger people could tell the difference between milks, as I've seen in my life, or regular milk drinkers. So maybe using all of them, or blocking using regular milk drinkers or people under a certain age. There also could have been lurking variables that we might have unaware of. They could have possibly confounded some of the results that we could have eliminated. And just looking at the line schedule right here. Ooh, 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 ooh. Wow. Maybe next year. Maybe next year. Okay. And that pretty much wraps up our presentation.